I may be wrong. You can choose whichever package you want. But I'm going to give you a kind of a template you guys so that you can start using it in a real life.
Yeah. Okay. Thanks, Sita.
Okay. So I'm going to give all the cheat sheets for you guys. If you look at the cheat sheet, probably I can show what is the cheat sheet. Okay. Download that. Okay, so if you look at the deploy to cheat sheet, okay, not this one. Yeah, I don't know where I copied. In the example, these are one of the cheat sheet for the visualization. Okay, it's maximum 2 pages. It will give all the functions you are going to execute using the package. It covers around 95% of the commands you can execute. It's like we use that cheat sheet in the exam, right? A small cheat sheet which will show many of the functions. So I'm going to give this cheat sheet to you guys for each and every library which we are going to execute. So it's like more like a quick reference. You can go through the package and you can keep this printout in handy when you're going to execute the project. That's more than sufficient for you guys.
Okay, Sita.
Okay. All this one, I'll put it into, in the Google Drive. I'll give the link later on. Okay.
Yeah. Okay, Sita.
So, I have, executed the same command like filter, the next command is slice. Okay. Filter is normally, based on what do you call based on certain columns, correct? I can filter out certain columns like month or year, whereas slice is based on the row position. Okay, so if I want to select a row between certain sections, I can use the slice command. So sorry. So if I want to see the records between 100 to 110, I can use slice command, because head and tail command will execute only between top and bottom. But in between, if you want to check some data, you can use only slice, because filter command will not work, because filter normally using the column which we have either from year, month or something, but slice uses the row index, the row numbers to select certain rows. So if you look at what I did slice, it takes the rows between 100 to 110. That means it selected 11 records, and we can visualize, or we can see that how the data in the middle of the record, how its data look like. So you need to understand that the difference between slice, the head, tail, and select commands. So slice, we'll take it from anywhere from the middle. That's what slice means. Here I selected from 100 to 110. Okay. So next command in the package, we are going to use is arrange. Arrange is nothing but sorting the data frame in a specific format. Sometimes we want to order by we use order by command in a SQL statement. Arrange is a similar stuff. For example, here I want to arrange the flights. Flight is a data frame which I'm uses in a year, month, day, and year time format. So I want to see that how much time the year time means it's flown in the particular form they have, like how much time it's flown from New York to Los Angeles, or any other place. So these are 3 or 4 columns which we are talking about. We can arrange in a ascending order, descending order, by just passing out one more parameter, like I can say the descending order or ascending order. I'm going to execute this particular command. So it's give the the detail about the arrange command. So it's more like a sorting out the record set in a specific column. So let me copy this command, come here and execute. For execute, I'm going to just run. So you can record, the data frame has been, arranged in a specific format. You can see that, it's arranged on year, month, day of the column, and then year time. Year time, start from the particular day, day and everything. So you can see how it's arranged. And if you want to do anything on descending, like I can do the descending of the particular day. I can say descending. So descending means it comes from for the particular month, it start from the last day of the month to to the first day of the month. So I can do the ordering on any specific format. So if you look at the day has been changed. The last time it is arranged by default, which is ascending. If I give the descending the particular function, it will do the reverse. So if you look at the data coming from the 31st. Similarly, we can do it for any of the column. We can do ascending and descending. I can do descending month also. So it's very simple. Just pass on the descending, and you can see that the operation will return for the December month. Okay, so you can see this, all the detail has been changed, like departure time, because for December month is totally different. Okay, so if you execute, either if you can execute head or tail, I can do the tail also. It will return the bottom records. Because when you execute, descending, it will be, the January month will come at the bottom, and December come month will in the top. Correct? Okay. So that's an arranging command. We can arrange the commands in a descending or ascending order. And the other thing is I can use the select columns. You can select only the few columns. So probably you guys are aware the select command. Select when we do normal select, we can say select star or select field 1, field 2 from the particular table. Correct? That's what we normally execute in a typical RDBMS or any kind of database like Oracle or SQL. So similar things we can do it here. It will choose only those columns. So instead of selecting all the 16 variables, I can look at only the 2 variables which I want to look like, how the data look like. So I can choose carrier and probably I can choose origin. So when I execute this particular command, it will execute and it will return only these 2 columns from the database. See here. So it will return only the top 5. So United Airlines and everything. So you can see how that we can execute here. Any questions, guys?
Not yet.
No, Sita.
Okay. Are you clear the concept, correct?
Yeah.
Okay. So similarly, there is another column, another operation called rename. The rename is required when we, create a new columns, or if you're getting a data set, the data set has, many times it will not have a proper name, say. So that time we need to change the column name to some other name so that we can execute. I'm giving you an example like how I can change that the column name carrier into something called airline carrier. Very easy, like just you can pass on the rename column. it will change the name into airline underscore carrier. The carrier name will not be there. So let me execute. You can see this, airline carrier has been changed. So previously it has, carrier. Now it has been changed to airline carrier. So the carrier name, the column name has been renamed into airline underscore carrier. So sometimes you will get a very, field name with a not proper naming convention. You can change it. These are things very important when you are going to execute, the modeling. You should have proper name. You cannot have names like, M11, M12, M13 because M11 probably a month and year. Probably M1 means January, M2 means February. If you have that kind of columns, when you're getting the data set, you need to change it to January, February, March. That's the best way to understand. Because at any point of time, when you are going to execute and when you are going to show it to the business users, they don't understand what is the M11, M12, something like that. They know what is the January, what is the February. That's naming conversion. So you need to change many times the data header into a proper format to show it to the business users. Similarly, distance, nothing but it will select distinct rows from the set of variables. This is a similar command we normally execute in SQL. Same thing we can execute in R. So here I'm trying to select what are the different carriers we have in the databases. Even though we have more than 33,000 probably 3 lakh flight information, but we need to understand what are the different variables. Okay, so if you look at the carrier is a unique character field. So if I execute it, will return various the type of carriers we have in the database. So it's nothing but we have 16 type of different data sets like United Airlines, American Airlines. I don't know what is the B6 and DL and the other information, but we can choose a distinct for any particular field. If I choose a distinct for a month, it will give 1 to 11 because we have maximum 12 months. So distincts always choose a distinct values from the database. Okay, so that's one thing, and this is very important. Operation. We will execute the operation many times in a deploy our package or probably in a transformation project. What it does, based on the existing column, if you have 2 columns, it will allow us to create a new column based on certain formula like sum, multiply, or any formula we can use, mean, mode, and it create a new column. So the operation very simple. I'm going to use function called mutate. So let me execute the function here. So I'm just explaining the head column. Head is always written that top 5, but I want to show to you guys how we can create new columns. So when you call mutate operation, we create a new column from the existing data frame. So this is the data frame value. I'm going to give it probably I'll use data frame which I already created. Okay, this is a column name I'm going to create, which is called new column, and this is the operation we are going to give. So this will execute properly. What I say, it will find out the difference between the arrival delay and departure delay. If it's normally find out what is the delay or exact delay from the particular flight information. So probably instead of new column, I can create that delay time. guys. I gave.
Might be a DFU will be the small letters.
Yeah, correct. Yeah, exactly. So see, I have created, new column here. Variable not shown. Not all the variable shown, but let me wait. I don't know why it's created. Let me execute again. So it's not showing this particular, the column here, but when I do the select here, I can choose, the particular column. So let me choose and display the column for you guys. So select flights, not flight. It's actually DF for me because that's the data frame I use. Carrier, origin, and probably I can show the delay time. Okay, it's not stored in the database normally, but because here we are not assigning to the data.
You give extra brace for the above command.
Is it? Oh yeah, correct. Yeah. No, because not only that, this is I'm executing, correct? So it's not. It's only runtime. It's not saving it to the back to the database.
Oh.
So so actually it should save. Probably I'll. See now I'm able to see 1, 2, 3 departure delay. Okay, not departure delay. So only still that field is not shown, correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 16 fields only. So okay, let me. See, now you're able to see that departure time. Again, it's against somewhere I created, okay, departure delay. Okay, this is a field I created, correct? Departure time I created. So delay time always, whatever field you create always will come in the last moment. So what I did, actually using these two columns, arrival delay and departure delay. So if you look at it, it's 11, it's 2. So departure delay, arrival delay 11 minutes and departure delay 2 minutes. So basically it's showing, it's
the difference will be 9. The 9.
9, yeah. So actually, if you look at the column, it's actually, we need to combine both. So if you look at, actual calculation, it came 9 minutes, 11 minutes late, and it departed, 2 minutes late. We can, you can see any way around. So whether we need to add it, that's it, we can leave it to you guys. How the calculation will be there.
Got it.
Okay. So actual delay will be, probably, it will be 30 minutes because it came 11 minutes late and it departures again 2 minutes late. So totally it's 30 minutes late. So like that we can create a new variable because the main out of data science, basically whatever data you have, you need to create a new data fields so that you can find out more information. Because many times, for example, you have only the date of birth, or you don't have the age. So that means you need to create the age from the date of birth field and create the age and keep it for in the data field. So that field will be useful for doing modeling in a machine learning. So like that you can create a lot of fields using mutate function. Transmuted is a similar stuff. Only things it will show only the fields we created as of now. So here I created, then I struggled to show that field, correct? Like where the field look like. So whereas when you do the transmutate, I can just, it will display only those fields. See here, so it created the new column in the flight and displayed only the column. So you can look at the column and you can, see the data fields later on. Are you able to understand between
yes,
transmuted and muted?
Yes, Sita.
Okay, fair enough.
I don't know about the remaining guys. I don't.
Yeah, guys, if you have any doubt in understanding, please stop me. But these comments you can execute. I'm going to share this particular, the file to you guys so that you can execute and understand. It has small bit of explanation also, so you can go through the stuff. Okay, so next is summarize. Summarize. Again, is going to summarize some certain functions. Here I'm going to use a mean function to find out what is the air time. Air time is nothing but how much time the flight was in the air. Because many of the airlines will understand that more time you are in the air, you are more profitable, right? So if you want to find out which airlines or which flights are flying higher than compared to other airlines, you can find out using the average or mean air time. So just I'm going to execute mean air time command to show. Okay, there is an extra command I given na.rm.2 which is nothing but if any fields has null value or doesn't have any value, we need to pass on the true. By default, it is false. Suppose if a particular column has null value, it doesn't have any value, if I'm not using this function, okay,
We'll throw the NA.
Yes, it will show the NA. Because this particular airline has some kind of null value. When I'm trying to do any calculation, if it has null value, then it will give null value. So what NA.rm.2 is saying that exclude those values and calculate for remaining values. So that's what NA.rm equal to true will do. So by looking at this one, I can see this, okay, the average air time of all the flights for 2013 is 150 minutes per day, okay, so that's what it's talking about, okay. So similarly, I can execute two more commands, sample underscore n, sample underscore fraction. So when sample means, you need to understand sample between, the head, tail, and select. The head and tail, you will always choose the record from, probably either from the topmost or the bottommost, and the select or probably what you call, the command slice, which will extract the information in a sequential manner. Like, head will select the sequential record from the top, tail will select the sequential record from the bottom, slice will take a sequential record from somewhere else, probably from the middle, 100 to 110. Whereas sample, you want to choose a random record from anywhere else, like, you select, somewhere else, from that record set, that's what sample commands means. It do not choose from, sequentially, it will pick up from, anywhere else from the data set, it choose certain set of records. So I'm giving like, sample flights 10. Okay. So it will choose a randomly 10 records from that flights database. It's not from any order or any sequence. So it choose like, you can see, the first record from the 6th month, second record from the 7th month, it chooses randomly. So that's what the sample record means. So it chooses the random 10 records. I can choose random 10, probably I can choose random 25 records. You can look at the data set how it looks like. So many times when you're doing the data analysis, you need to choose sometimes the random record to see how the data looks like. So whenever you execute the random, it always it returns different records. So if you choose, 10, 8, 11, something, chooses different records. The first record from the 10th month, the last record from the first month. If I execute again, it will return a different set of samples. It will not be the same. See, it chooses from the fourth record, it chooses from the eighth record. It chooses always the different data sets. The first one is from the United Airlines. Here something called UE. So it always chooses the random record. It is not same. And sample fraction is nothing but previously we selected a number called 10. Here we can choose a percentage. Okay. So if you look at the percentage, it will chooses the percentage from the data frame. So we have around 0.3 million or 3 lakh records. I can choose sample fraction. Okay, sample fraction copy. I can choose so I create a data frame called fraction or fraction, 5%. Something I'm going to create. I'm going to choose, 5%. Yeah.
Notation is wrong.
Yeah. I know. I saw that. Yeah. Right. Okay. So I can choose a sample fraction of 5% of record from the flight, and I can assign to a new variable, and you can choose how you can select. Okay. So why this is required when you are going to get the data set in a huge volume, probably millions of record, in R everything will be loaded into into your memory, computer RAM. So that time, you need to choose only fraction of the record to, for modeling or probably for visualization. You can choose top 10%, and you can see how the data look like, and you can see that one. So if you look at, the records that I created here, I created the top, probably the 5% of sample from the existing, data frame. So if you look at the 5%, it comes around, 16 or 17,000, which is correct. So I can see that the record set probably head of so it will display that the top 5 from the record set. You can look at it's created from the sample because the values are different. Like first record from 6th month and 27th date, second record from the first month or 20th date. Like that, you create the sample from various sources. Okay, that's what sample means. We can perform various operations on the deployer package, but whatever I shown is only your top 5 or 10 commands. I'll share this entire the data sets, the tutorial to you guys. You can look at later on.
Okay, Sita.
Okay. So any questions so far, guys? Before we move into the next one.
I don't have any.
No questions.
Okay. So like deployer, another package called TidyR. TidyR also, very important, manipulation command. So let me, okay. So data table is a existing package within the R. So we can, this also like, we can visualize, data in a more like Excel format. We can do a lot of things like, what we do in Excel, we can do is in data table. Okay, again, I need to install. So it's installing it, and I can use library.data. Okay. So, there are two ways we can look at the data. One is data frame and the data table. Data table is, is just the extension of what we have data frame. But it is very fast compared to data frame, and syntax is very clearer, because in the data frame we need to use a lot of complex syntax when we want to select or filter out information. But data table is just a layer or a wrapper around the data frame, and you can execute a lot of the complex command in a smaller way. So in a TidyR, we are going to use the 4 commands. We are talking about gather, spread, separate, and evaluate. These are the 4 commands. The basic commands which are topmost used in the TidyR package. So I have get some information on gather, like gather is nothing but if you have multiple fields, like you have month 1, month 2, month 3, and you have values. Month 1 is 100, month 2 is 200, something like that. You have various values. Actually, it's a duplicate. Like month 1, month 2, nothing but we can convert into one variable called month. We can put January, February. So if you have data sets like January, February, March, April, and it has some values like sales data, order data, you can convert the entire the 12 months, January, February, March, into 2 columns, like a column called month, which will have various values from January to February, and its corresponding values, like it has 100 or 200. So basically, gather nothing but gathering a spreaded data into a key value file. Okay, so I'm going to give a small example here. Like I'm going to create a data set, okay, from the list value. Okay, so let me copy and execute so that you can understand what the commands. So let me go here, create a new script. So that it's a component. We are creating a list called a component which has various values. It has around 9 records. The first record is I'm showing it here, C1. Then I'm creating another list called year, which has from 1998 to 2000. Then I'm creating a 4 quarters. The 4 quarters will have a random value between 0 to 1. So quarter 1 will have 9 values because we have 9 records. So for each record, when you see this, it created 9 random value for each and every row. Similarly, quarter 2 will have. Let me execute. Probably you can see this. So similarly, I'm going to run in quarter 2, quarter 3, quarter 4, all these values, and from that I'm going to create a data frame. So let me execute quarter 1. The run is nothing but it created random 9 values. The minimum value from 0, maximum value is 100. So like that, I can create a random values. FLDA means I have created a 6 list using some random values. Okay. From the 6 list, I'm going to create a data frame using the command data frame, and then these are the values I'm going to use. So when I see that the data frame, you can look at the values. So we created a data frame. The data frame, nothing but create a data frame using the list. These are the lists I created manually. So component 1 is component, probably 1 to 3 component. These are the various sales for the particular quarter. So component 1 in 1998, in the volume is 78 for the quarter 1, quarter 2 is 72, and quarter 3 81, and quarter 4 is 23. So it created a random value and created a random a data frame which shows underlying values. So if you look at if you look at the bottom, the last 4 columns, it's actually a duplicate. I don't want to create a separate column for quarter 1, quarter 2, quarter 3. Rather, I want to create a data frame like component. So I'm showing it a year. Then probably a field called quarter and volume. I want to transform this particular data frame, which has structure like component, year, quarter 1, quarter 2, quarter 3, quarter 4, from the 6 structure to 4 structure like this: component, year, quarter, and volume. How we can do that? That's what we are going to talk about. This gather information. How I can gather? Okay, I'll explain the pipe operator later on, but the gather, I can convert the entire information into like this. So I'm going to create a new, data frame new. I don't want to use here, I want to transform everything into new data sets. Okay. So what exactly do? So, piping operator, nothing but, I can explain the piping operator in another 15 minutes. Actually, what exactly it does, it takes, a data frame, give it a piping up, pipings, normally we use the water pipette, pass this data frame into a function called gather. Okay. What gather will do, it will create a new field called quarter and revenue. Okay, these 2 fields will be created, and from the existing field, what are the fields we want to do it from quarter 1 to quarter 4. So typically it converts the 4 fields from quarter 1 to quarter 2 into 2 fields, and the new fields will be called quarter and revenue. So let's see, let's see the output. See here, how it's transformed the existing data frame to new data frame, whereas quarter 1 is 75, we have quarter 1 75.471, we have 4.71, quarter 2 like that is every quarter will be converted. The quarter 2 has 97.21, we have for 1999, for 2000 we have 82. So it will convert the 4 fields into 2 fields with a different naming conversion. So we can convert easily into new columns. We can arrange, transform, transpose. In the Excel, we do a lot of transpose functionality, right? So it's more like a transpose from the column format into row format.
Yeah, Sita, and the new one gives the 36 observations, right?
Yes, correct. So you can see this, 36 observation. You can see the 36.
So
here.
what we did? Yeah, I got it now. So okay.
Okay. So if you have a month, if you have a month like this, that means we have 12 months. Okay, and then it will become 9 into 12. It will become what 90 108 rows. Okay.
May I know the use of this type of gathering, because anyway from the 9 observations table we extended to 36 observation table, right?
Yeah.
So
many times, we wanted data to be in the particular format, because when you collect the data from the ground up, from the business users,